Good morning, everyone. It's great to see you all this early. And because we have Aussie Rules lightning talks this time, the lightning talks are before the keynote, and they're 15 minutes long. A little weird. The actual title of this talk is Achieving Harmony Between Serverless and Traditional Applications. But the talk that this morphed into is Mudball versus Spoon. You have existing applications, SOA, an existing monolith, whatever you have, and you want to go serverless for the benefits that you are all going to be hearing a lot about today and have already heard a lot about yesterday, so I'll skip it. A little story time. A migration that I did was from a traditional, very standard Amazon architecture with a couple auto-scaling groups providing different services over HTTP, Ansible for automation, and some Lambdas in the back doing glue-type actions. And towards serverless version 0.3 or 0.4, we started using the serverless framework to manage individual Lambdas that did things like handle EBS snapshots, talk to Cognito for syncing, and just the parts of Lambda that are integrated tightly with other Amazon services like config rules. And after that, the first pilot HTTP service came out. And the team wanted to set an achievable, measurable goal that had a defined benefit, and that was replacing the entire worker cluster that handled asynchronous jobs, so things like Sidekick and rescue jobs, in addition to cron jobs, things like sending out newsletters, all that fun stuff that you have when you run businesses where you have to talk to people on a regular basis so they remember who you are. And I'm happy to report that a couple weeks ago, we did the final ceremonial termination of the cron/worker cluster. But there were a lot of lessons learned there, and I hope that this can help you as well. The order of expensive tasks was flipped from what I expected. I expected rewriting jobs to be in Lambda-supported languages to be the hardest part. That was actually the easy part. The hardest part was to break up all the shared memory concurrency that was built into all of these jobs. So you have things like strings of bash scripts or Perl scripts or Node that transfer either large amounts of text or JSON blobs or are in the same process and using IPC. Breaking all of that up into Lambdas was the hardest part because you have to change the model of the code to match with your event source, and then you have to connect your existing legacy application to the new event sources. So those were the two most expensive things. And rewriting was actually by far the easiest, because once you have code that works, it's really easy to get other code that works from there because you have a starting point to test from. So this was the process that we followed for migrating to serverless. It started out small. You write your first Lambda function for something very small, easy, maybe handling a Slack hook, using Cognito triggers, AWS config rules, any of these services that have Lambda baked right in. And then you can move on to backend tasks. And I really like this as a learning tool because backend tasks tend to be asynchronous, so a lot of objections about we don't know exactly how well this is going to perform and things of that nature. All of those are non-objections for async jobs. And so you can take a lot of different jobs that you're getting from Sidekick, rescue, scheduled events, all of these, and wrap them in Lambda functions and use event streams like Kinesis and databases like DynamoDB to handle your scratch space and all that. And then once you've learned on the asynchronous bicycle, you can move to the user-facing critical path motorcycles. That's when you start replacing major pieces of functionality in your app with either an API that is being talked to from your web application or something that users are going directly to over the AWS SDK from the mobile app, or from a mobile app, rather. And as you saw with where I started was on a mostly cloud-native application already, so Ansible for automation, auto-scaling groups, everything was very nice. And the further right, or the further left you go on this slide, the harder your migration to serverless is going to get, because when you're starting on-prem, you're going to have to learn account separation, credentials management, and a bunch of other things in addition to serverless technologies. If you're coming from virtual machines that are long-lived and somewhat automated, that's going to be a slightly smaller jump. And if you're coming from, you already understand how to handle auto-scaling groups, you're doing things in CloudFormation or Ansible, moving to serverless is going to be a lot easier for you because you're making a much smaller jump. So that's the nice part. Now I want to talk to you about the parts that, when we started, were what I would call the unknown unknowns. And the biggest problem that we have, or the first problem that we hit, was scaling. When you put thousands of jobs into a queue and Lambda is just listening, Lambda will happily start thousands of Lambdas that will happily ruin your database. Because if you have a legacy database that's sized for what you used to have, where you had a couple of job servers that were hitting the database constantly, now as you're reacting to events, if you have big batches of events, you have big spikes of load on your database, and that's going to cause you problems. So to deal with this, we introduced a lot more back pressure in our queuing system, figured out how to prioritize user interface tasks by moving all of the serverless stuff that needed the SQL databases to go to only read replicas, and denormalizing data about jobs into the messages that trigger the jobs. So instead of kicking off a Lambda and then having the Lambda gather all of the data that's necessary, if you have the data when you kick off the job and you just don't have time to do it, you put that all into the message, and you can send that along on your queue. The two major event streams that we used were Kinesis streams and DynamoDB streams, which we'll get to in a little bit. But Kinesis's built-in retries are usually good, but sometimes not what you want. If you have a Lambda that is failing for some reason, it's going to block that Kinesis shard indefinitely until that Lambda passes with that data. So if you are not careful, you will have 10, 15 streams, or 15 shards rather, that one of them is not processing jobs and you have no idea, unless you're monitoring things like the iterator age and the failed invocations of your Lambda function. The other nice thing about Kinesis is it has sort of that built-in smoothing capacity, because Kinesis can take as many reads as you want to throw at it, but if your Lambdas are only processing messages on the shards that are available, you're only going to have 5, 10 Lambdas operating over your 5 or 10 shards, and that automatically smooths load on your legacy systems and APIs. There are some services that cannot fit the entire event into the trigger for the Lambda, notably S3, because it doesn't have all of the information about where that S3, about the contents of the S3 blob or the context around. So your Lambda is going to still have to go out to databases and find user IDs and other information to associate with your files. SNS has a tricky gotcha, which is the Lambda invocation size is smaller than your SNS message. So in test, it works because your messages are small. And then in prod, you have sad times. And to catch a lot of these little sad time causing things, the dead letter queue is really nice because you can take that poison pill data and shuffle it off into SQS or onto an SNS topic to either be dealt with manually and looked at by devs, sent an alert, or handled by another Lambda. For dealing with jobs, DynamoDB is a really great scratch space, even if you can't use it for your entire data store, because you can kick off jobs by creating a DynamoDB row and having Lambdas that listen for those create events and that are coming off the stream, and the stream includes all of the data that you need to handle this job. You get the hash and range key, so you can get the item directly from Dynamo or write directly to the item with no queries or scans, so you save on capacity there. You get the new and old versions of the data if there is an old version. And to keep your table small and costs down, you can use TTL to expire the records from old jobs as they age out. So you have an audit log that might last 2 weeks, 3 weeks, and then after that, it TTLs out. The TTL feature is great, and it's new, and I am so glad that it was added. The way you introduce back pressure with DynamoDB is actually really elegant, because DynamoDB, because you have capacity limitations, has a natural back pressure of this is how much capacity you've provisioned, and if you have too many Lambdas, you start getting denials, and then things shift off into the dead letter queue. Or if you have something that's starting jobs by writing DynamoDB records, it can get the write and read capacity available on your table back and make decisions about how many jobs to start at a time based on how much of that pipeline is available. And in the advanced mode, you can use auto-scaling, you can use Lambdas to auto-scale your workspace for Lambdas. so that you can decide how many Lambdas are allowed to be running and manage your capacity and costs based on that. The next thing is monitoring. This is especially hard when you are split across serverless and traditional systems. The most important thing is if you do not have good logging practices already, you absolutely, absolutely need to get them if you're putting user data in Lambdas. Because you will have Lambda functions that fail in odd ways, and you can't SSH in and check things out. You can't go in and try new code on that specific record. You have to have logs so you can duplicate this problem in dev and then fix it. You can use CloudWatch connectors to ship your logs around wherever you need. And the most important thing for operators and your developers that are managing these applications is having a central place to go for the logs for your legacy applications and your new applications. If you have to open 4 different dashboards for logs for this system, logs for this system, logs for this system, oh, and CloudWatch now, you're going to have some outages that are going to take longer to resolve than you want to. The best resolution for this that I've found is using structured logging. So instead of thinking of logs as information about your application, they are events inside your application that are not just strings that are written by the developer, but they are built for being read as event sources themselves and to be analyzed just like the data about your running production system that they are. There are a lot of libraries for this. My favorite is structlog in Python, but every language has an equivalent, even if it's just json.stringify. And you can use CloudWatch filters, you can use Splunk, you can use the Elk stack to pull metrics out of these structured log messages. For example, this one is a very simple login, so it has the source of the login, the version of the client that performed the login, and so this is a JSON object that's being logged out, and you can find this in CloudWatch, and you can have metrics on, using CloudWatch filters, you can add metrics on things like the event type, so you can have a metric of the number of successful user logins that you've had over time, and if that goes down to 0, you know that no one likes your stuff, or your stuff is broken. But it's up to you to figure out which. Structured logging is a great tool in your toolbox for providing central visibility into what's going on in your system and how your code is performing on real data. You can forward your CloudWatch data into Elk, which is what I've done in the past. You can use Splunk, you can use Graylog. There are any number of logging solutions available, and most of them have a way to parse JSON logs and pull out metrics and information so that you can see across your legacy and serverless architectures what is going on with your code. And you can get application information from your logs, not just information on how your code is running, but business level metrics like when things are purchased that other parts of your company are going to want. And so if that data is structured and easy to get, it's easier for them to make business decisions based on what's happening in the real world instead of flying blind. The last topic I want to talk about is code bases. If you are starting a serverless application, your first instinct is going to be make a new repo. And if you are rewriting existing services to move to serverless, I cannot caution you against this enough. Because if you are moving code, having a monorepo helps you a lot because it keeps attribution, you can watch code as it's moved, and you can do atomic changes to the full repo if you're doing things like changing your logging library, if you have pull requests that change the way that events are sent around your application from internal method calls. If you have something inside of your monolithic application and you're moving that out to Kinesis, you can take everywhere an event is generated and replace it with a call to Kinesis in one pull request and have that reviewed and tested all together at once. So cross-cutting changes like that become a lot easier when your serverless and traditional applications are together in the same repo. If you have smaller individual repos, you can do a lot of the same things, but there's a lot more overhead if you have to sync up the versions of some things on your private NPM, and then deploy them, and then update the package.json on your production service, and then put that all back together. Or worse for code sharing, if you have submodules and developers forget to update the submodule when they're testing, and then it gets pushed, and then you have problems. Your deploy pipelines really have to be independent, and this is important because you aren't going to be able to sync up Lambda deploys with everything else. I'm running quite low on time, so if you want to hear more about deploy pipelines, do find me. And my slides are available at harmonize.serverless.zone. And I'm going to put a text version of this talk with the video. Everything's going to be on there, and you can hit me on Twitter as Ryan_SB. So thank you all very much. It has been a pleasure.